Yes, class. Am I audible to all of you? Alia, Siddiqa, Martin, your network issues. Martin, am I audible? And what about you both, Alia, Siddiqa?
Yes.
Is it audible?
Yes, ma'am.
Okay, okay. See, let's start. One more thing was left in the last class, which I was telling you. Yes, elastic collision in 2 dimensions. So I was saying the last class also, I told you the same thing, that in elastic collision, velocities will actually be resolved. So this is one velocity which is acting. This is V1 velocity which is acting. Now in elastic collision in 2 dimensions, we are using the term 2 dimensions. So 2 dimensions means the velocity plane, right? We had motion in a plane that was in 2 dimensions. 2 dimensions were involved. So it cannot be fixed, no, that both the bodies are coinciding and they are remaining as it is only. It can happen that to a certain angle they are getting bent and they are moving further. Yes. So same thing also here, M1. This is moving with velocity V1. This is moving with V2. All right. So what we'll do, we'll resolve both the vectors. This will become V1 cos theta. This will become V2 cos theta. This is V1, this is V2. So see, if this is V1, we are resolving the axis. This one will become cos theta because the angle is being made with the axis. So that is V1 cos theta. And the perpendicular to it is V1 sin theta. Similarly, you have V2 over here. So V2 cos theta and V2 sin theta. Now what we have to do, we have to resolve both the velocities and calculate momentum along different axes. First, talking about x-axis, what do we have along x-axis initially? Here we have M1U1, right? Here we have M1U1. This means this part, when we are talking about this is M1U1. This is M2U2. Now, M1, U1 is the velocity. U1 is the velocity, initial velocity of the first mass. U2 is the initial velocity of the second mass. Right? So, momentum will become mass into velocity. Chavez, this is yes. So, M2, U2 is the second momentum. So, what will be the conservation of momentum? M1, U1 plus M2, U2. This is the initial one. Now, finally, what is happening? How will you take the velocity? We used to take M1, V1 only, right? Now, this will become M1 into V1 cos theta. Yeah, instead of just taking this as M1, V1, we'll be taking this as V1 cos theta and that one as V2 sin theta. So, this becomes M1 V1 cos theta 1 plus M2 V2 cos theta 2. Now, when we are resolving along y-axis, see, we do have V1 sin theta over here. We do have V2 sin theta over here. But we do not have any value of velocity along y-axis initially. So, what will be our formula along y-axis when we are taking? Before this will be 0. After this will become M1 V1 sin theta 1. And see, both are opposite. So, this becomes M2 V2 sin theta 2. So both are equal. M1 V1 is equal to sin theta 1 is equal to M2 V2 sin theta 2. Fine. Now see, kinetic energy, since we know kinetic energy is conserved in elastic collision, what will be the kinetic energy also if you have to calculate? Half mu1 square plus half u2 square is equal to half m1 actually, m1 here, m2, m1 v1 square plus half m2 v2 square, like this. All right, just an addition, whatever you studied here, same thing, same thing. Just you will be having y-axis equation separate and x-axis equation separate. Note it down. We'll start with center of mass then. That is your rotational motion, the next lesson. Note it down. And plus, I think the speakers, my speakers aren't working well. So it can happen if you're saying something, I'm not able to hear it. So do one thing, type it in the chat column. All right, the speakers aren't working well in the laptop. Yes, class. Now see the next lesson, that is chapter 7 of your NCERT. This is the second last lesson of the first book. That is motion of system of particles and rotation motion. See class. This in this lesson we are currently talking about the rotation motion that is occurring. So see, rotational motion, some portion of it we have already studied in your previous lesson. So circular motion. So remember we had talked about angular acceleration, angular displacement and all. So that portion I'll not be repeating, but that will come again. We'll be having kinematics of circular motion that is left. So that we'll be discussing. All right. So motion of system of particles and rotational motion. So first topic that comes into action is rigid body. When we are talking about a rigid body. Rigid body is a body that has a definite shape and size. Means if compressive forces are acting. If compressive forces are acting on it, then still there isn't any effect on the body, right? So definite shape and size of the body, this is known as a rigid body. Now during motion, separation between 2 points on rigid body does not mean. This means what? See, what is exactly definition of a rigid body? Whatever you know the meaning of the rigid body, this is exactly the same. It's just to define it, because I'll be using the term, and in your questions also you will be having the term rigid body. So body having definite shape and size during motion separate. This means, see, this is a body. I am taking 2 points. Let's say this is 1 point A, this is 1 point B. Let's say the separation between these 2 points is 3 millimeters. So this body, this has started moving. This is start moving. This is A, this is B point. This will still remain as 3 millimeters. The difference will still remain as 3 millimeters. So rigid bodies, the points do not change. That's why it makes our calculations easier. Otherwise, if the points would have been changing, we would be required to calculate the mass and velocity and everything for a single particle inside a big object. Understood? So since we know that the distance is remaining the same, what do? Instead of the entire body, we just take a point, and that point is called center of mass, which I'll be telling you soon. Before we start with center of mass, certain things you have to understand. The system of particles, the name of the lesson, system of particles, system having more than 1 point. One particle is itself, but when more than a single point mass comes, that means it's a system of particles. Now, you will be also getting these terms: discrete system of particles, continuous system of particles, discrete masses, continuous masses. This means, see, suppose I have 3 masses. M1 is there, this is M2, then this is M3, then so on. All these particles are continuously present on each other. This means these are continuous system of particles. In discrete, all the particles are separate from each other. You can observe a proper gap between all the 3. All right, this is what is meant. And we'll be dealing with continuous only, because all the particles are intact. Now this is acting to you as one single object. Clear? So this is system. This is the introduction to your lesson. We have no motion of system of particles. We are not talking about a particular motion of this element which is present inside it. No. We'll be talking about the entire block, entire mass. We'll be talking about this entire block, entire object will be considered. But it's obviously difficult for us to calculate every point. See, it is made up of so many molecules, so many masses. Every molecule is having so many masses. How many molecules will you consider? Velocity of which molecules will you calculate? So for that, we have a concept of center of mass. That's on the topic of which this revolves, motion of system of particles. And rotation motion, some portion which we have already started, it will be a continuation of that. Center of mass. See, types of motion in rigid body, let's do till here, then you can note it down. Translation motion exists, means the body is moving to and fro. or up and down. That is translation, means in a straight line. Rotational motion means there is rotating effect on the body. Now, when the body is rotating also and moving further also, that is rotation plus translation. That is known as rolling, like the tires. See, if you are sliding a brick, that will be translational motion. If the fan is rotating, fan is not moving further, no. The fan is fixed on the ceiling. Fan just rotates, it doesn't move. But when we talk about tires of the cars, they are moving further also and they are rotating also. So that is rolling motion. So rolling motion we have to discuss. So we'll be going through this lesson in 3 portions. First will be translational motion part, second rotation motion, third rolling motion. Rolling motion also, for understanding rolling motion, you have to have the concepts of translational plus rotation. Out of these, among translational, you have the most important topic that comes in your exam is center of mass or moment of inertia. The moment of inertia is actually in rotation. From translational motion, you have center of mass. From rotational motion, the equations, the way similar equations which you have studied in motion in a straight line, those similar equations in rotation, as well as your moment of inertia. This is very important. And in rolling is a very small topic itself. So this entire topic is very important. So we'll start with translation motion, in which we have the concept of center of mass. Let us discuss that. Do one thing, note it down first, the introductory part of this lesson, chapter 7.
Can you go back up? Can you go back up?
See, yes, I was talking about the center of mass. Now see, center of mass is just a point that you assume to be concentrated where the entire mass of the system is concentrated. See, suppose this is a block that I have, fine? This is a mass. There are so many particles which are present in this. The system of particles which we talk about, that is the name of your lesson. So many particles present in it. Now, when the block will start moving, each particle will start moving. This will also be having a particular velocity. This will also be having a particular velocity. This will be also having a particular velocity. This will be also moving with a particular velocity. So how will you find out the velocity of this? How will you calculate the force on each particle? What will you do in such case? Because if I am asking you what is the, suppose I have given you a question. I have asked you people, what is the force on the system? So how will you calculate the force? When I'm saying there is no one definite value, see, initially before this lesson, whatever you have studied, we just studied if this is a car is moving, force is this, v is the velocity, acceleration is of the entire car, right? Now we are going into the details of it. If a car is moving, if a particle, if an object is moving, that velocity v which we used to take in our calculations, what exactly is this velocity? Or when we used to take force is 5 Newton, mass is this 5 Newton force is being applied. What is this 5 Newton? Because if we look microscopically, you will notice that there are so many millions and millions of particles which are present. So every particle will be having a different velocity, different force. This particle will be having different velocity, different force, different acceleration. So how can you decide which particle's velocity will be considered as the ultimate answer for the entire block? It's difficult. It's obviously difficult for us to calculate all the particles that are present within, right? That are present within the object. So what we do, we just take one point and we assume that entire mass is concentrated over there. Entire mass of the system is concentrated over there. And that point we call as center of mass. Center of mass is this, like this. Even if suppose this is the center of mass. So I can replace this entire brick and I can just place this. It will be acting exactly like this. It will be a notation for this. Now, whatever velocity of this center of mass I'm taking, that will be the velocity for the entire particle. It's just a way to calculate. Otherwise, if we consider all the particles which are present within them, so many particles are present within them. If we start considering them, all these particles that are present, then we won't be able to get the fine. All right, we'll be able to get it. Clear class? This is why we consider center of mass. This is the reason why we are considering the center of mass. All right. Suppose this is a disk. At the center, we are having a center of mass. And it's not necessary that you are having the center of mass inside exactly at the center of the body. No, center of mass can even lie outside of a symmetrical system as well. It depends on various conditions. This we have to study. Note it down, then properly I'll tell you the formula part because this is the theory part. Note it down. Class done. Can we come to the formula part? Did you understand the concept of center of mass or not? Yes, Abdullah. And what about others? Alia, Martin, Yasir, Siddiqa? Here or not?
Yeah,
Okay.
ma'am.
Yeah, Martin, what about you? Did you understand the theory part? Then only we'll proceed towards the numerical part. It's just that for you can center of mass is this point. No, if suppose the body center of mass is this, so I can replace the entire system with just this center of mass. All right. Now coming to the formula part. See, suppose this is M1 is the mass over here. Then R1 is the separation from the origin. M2 is the mass, R2 is the separation, Mn is the mass, n number of particles are present, Rn is it. When I'm talking about this becomes x-axis, so x coordinates are present. When I'm talking from here, this becomes the y point. And at the end, I have taken a resultant center of mass. This resultant center of mass, which I'm talking, this I'll be calculating. This I'll be telling you the formula. So remember, the formula goes like this for every point. M1 into R1 plus then M2 into R2. Fine. Then keep on plus M3 into R3 plus M4 into R4 plus M5 into R5 like this. And on it goes till Mn into Rn divided by total mass of the system that is present, like M1 plus M2 plus M3, M4, Mn, like. This is the net result. All right. Now, when we are talking about specifically, if we are talking about the x-axis, if we are just talking about the x-axis specifically, so this x coordinate, this will become xcm will become c m1, then x coordinate of it plus m2, then x coordinate of it till mn xn divided by total mass, so m1 plus m2 plus m3 till mn. All right, if suppose you are having y coordinate, you want to find out y coordinate of center of mass. So this will be m1, then y coordinate plus m2, y2 coordinate like this. Then mn, yn. And what will be the mass? m1 plus m2 plus m3 till mn. If suppose you are having z axis, so this will be m1, then z axis separation plus m2, z-axis separation like this. So this becomes Mn, Zn, M1, M2 till M. Like this, this is the formula. The formula is not difficult. It's just that the applications you have to understand. Note it down. I'll show you how to practice questions on this.
Ma'am, that's M4. Right?
See, now we have to calculate the position of center of mass. Now see, for this we have to have all the coordinates, right? X1, Y1, Z1. This is how we write in the formula. Masses are given. So when we are talking about center of mass, this is given in a plane. So we'll be calculating XCM separately and YCM separately. Because this is not a 3D object, so you don't have Z axis involved over here. Now, please listen to this question carefully. If this is the axis, what exactly is the point here? This is 0, 0. This is at the origin. This is 0, 0. Fine. So it means the x1, this is the value of x1, this is the value of y1. Fine. M1 is 1, x1 is 0, y1 is, this is clear. Coming to 2. See, if this separation is given as A, and what is the, if I give you this point, it's like this separation is A, and on this point, I'm asking you the coordinate. So what is the y coordinate on x-axis? Nothing. No value of y. So this y will be 0. What about x? X value is given over this part. X value is given over here. So this becomes what? A, comma 0. Why? Because this separation is A. So this becomes x2, 0. This is 0. That is y-axis is 0. So y2 is 0. Now this was easy. This was the easiest. This was also fine. What about this? How will you calculate now the point? See, we have to find x2, x3 and y. See, x3, what is the separation of this point from x-axis? This part. This is exactly half of it. So this becomes a by 2. Right? This becomes half of it. So this becomes a by 2. Now, how will you calculate the y coordinate? So, see, y coordinate is actually given by this part. This is what? We need to find out this, right? If this is a by 2. Look here, class. This we do not know, no? This we calculate, this is a by 2. So we have the x part. What about the y part? Y-axis is the separation, that is this part. It means this length. So this side is a, this half is a by 2. So using Pythagoras theorem, will not you be able to calculate this? Under root a square plus a square by 2. So that becomes 4a. So this becomes root 3a by 2, right? This is root 3a by 2. And what is the mass? Mass is 3 kg.
How do you find the coordinate of the third point?
Hypotenuse was a, base was a by 2. Now we have all the values present. Let us solve this. This is m1 x1 plus m2 x2 plus m3 x3. m1 plus m2 plus m3. Now, what is m1? First mass is 1 kg. What is x1? This is 0. Plus m2, mass is 2 kg. What is x2? This is a. m3, that is 3 kg, multiplied by x3. x3 is, see, this is x3, this is by 2. x3 is a by 2. So total mass becomes 1 plus 2 plus 3. So xcm, this becomes, this is 0, this is 2a plus 3a by 2 divided by 5, 6. This becomes 6. So when we take the entire LCM, this will become 6. So that becomes 12. 5a plus 2a, that is 7. 7a by 12. That is the x coordinate which we have. Similarly, you will calculate the same thing for y. CM also the center of mass for y. This becomes m1 y1 plus m2 y2 plus m3 by 3 divided by m1 plus m2 plus m3. Now substituting all the values. What is m1? m1 is 1 kg. y1 is 0 plus m2 is 2 kg. y2 is also 0 plus m3. m3 is how much? 3 kg. And this is root 3 a by 2. Yes. And this is 1 plus 2 plus 3. So this will become, see, this is 5, 6, and then 3 into 2. So that becomes, we'll take the LCM. This will be root 3a by 4. This is YCM. YCM, XCM, this is how you calculate. All right. Note it down. Try it yourself first. When you are getting stuck, then let me know.
2a plus 3a is 5a.
Yes, class completed. XCM should be 5a by 12.
Yeah,
See, this is 2, 4 plus 3, 6, 7. Yes, 7a by 12. This is 3a by 2. So 2, 3a plus 3a by 2 it is, no? So when you take the LCM, this becomes 4a. 4a plus 3 is 7a. Yeah?
yeah, ma'am.
Okay. See, one more point that you should note down is that, see, if the masses are equal, then the center of mass will be at the center. All right, if it is inside the body, it will be at the center if the masses are same. But if one mass is greater, one mass is heavier, the center of mass lies near the heavier mass. So COM will lie near the heavier. This is one point that you have to remember. Other than this, if you are having variable values of center of mass, like right now we were talking about definite masses, x1 value was fixed, x2 value was fixed, x3, all these values were fixed. Then masses values were also fixed. So see, if suppose somehow these values are variable, then what we do? Integration of xdm, ydm, zdm divided by total integration of dm. This means total mass. This is how you will calculate the total mass. But many times we already know the total mass. So instead of writing this, we directly write it as m. All right, this is how you calculate. Note down these points and we'll practice one question on variable also. Okay, class, we'll continue this in the next class. From this, we'll continue. Please revise center of mass and form. All right, on Thursday, we'll continue the rest of the course. Thank you so much. Those who have completed, you people can leave.
Thank you, ma'am.